It began without headlines, without alerts, without any of the fanfare that usually accompanies a major space event. There was no countdown, no press conference, no dramatic feed from mission control. Instead, one by one, the world's eyes turned skyward and then went silent. In mid-October, at 02:11 UTC, a handful of communication engineers in Maryland, Madrid and Canberra noticed something strange in the telemetry logs. Dozens of satellites, civilian, scientific and military, had quietly repointed their high-gain antennas toward the same coordinates, not toward Earth, not toward the Moon, but toward a region of deep space trailing 3 Atlas. The adjustment was subtle, precise, and coordinated. Within minutes, relay bandwidth reserved for ordinary weather and communications data began rerouting through encrypted channels. Routine data packets vanished behind classified access points. To the public, the systems appeared stable. To those who knew what to look for, it was the digital equivalent of the world holding its breath. NASA's official explanation came hours later, a network synchronization test between partner agencies. Short, harmless, bureaucratic. But synchronization tests don't usually involve redirecting orbital assets worth billions, nor do they trigger automated readiness scripts in defense communication networks. Something had changed in how 3i Atlas was being handled. The agency called it routine. The pattern said otherwise. At Jet Propulsion Laboratory, telescope time was quietly reallocated. Deep space tracking antennas originally scheduled to monitor Voyager 2 and the Artemis communications relay were reassigned for non-standard calibration. Engineers on the ground noted that the signal timing windows matched the expected position of the Interstellar Comet as it slipped behind the Sun. Yet the orders came not from planetary science divisions, but from the Department of Defense Liaison Office embedded within NASA headquarters. That's the part they don't publicize, the invisible bridge between exploration and protection. Somewhere in the bureaucratic fog, a single phrase began appearing in interagency memos: continuity of space operations. To most employees it meant nothing. To those who recognized it, it was a quiet alarm. That phrase only appears during solar storm contingencies or potential impact threats, moments when the continuity of communication between Earth and orbit must be preserved at all costs. But there was no solar storm, no incoming asteroid, no declared emergency, only a cold, silent comet millions of kilometers away. As the adjustments rippled outward, ground stations in Guam, South Africa and Argentina switched to secure frequencies. Amateur radio enthusiasts noticed narrow-band interference patterns sweeping across the 7.8 GHz range, identical to those used by deep space radar experiments. But those experiments had been suspended weeks earlier due to budget restrictions. Someone had quietly turned them back on. By morning, the pattern was unmistakable. Global coordination without public coordination. Every system that could track an object beyond Mars was now, in some capacity, doing just that. The European Space Agency's Cebreros station in Spain went off its live public feed for maintenance, a rare and suspicious occurrence. The Indian Deep Space Network stopped publishing real-time signal metrics. Even commercial telescope arrays like Starlink's private sensors showed brief service interruptions. Whatever the reason, the world's vision of the sky was narrowing, funneling toward one object. Inside NASA, staff described a subtle shift in mood. Meetings that had once been open became invitation only. Daily mission briefings started requiring clearance levels normally reserved for defense liaisons. A new internal directive circulated under the heading Operational Posture Elevation, Tier 3. No explanation, no public notice. Just a tightening of the chain of communication. In the archives of NASA's internal network, Tier 3 corresponds to information control during ambiguous orbital events. Ambiguous. That word carries weight. It doesn't mean dangerous. It means something that can't be explained yet. Something that could shift from scientific anomaly to strategic concern with a single new data point. Across the Atlantic, the European Space Operations Centre mirrored the pattern. Their internal message boards, normally buzzing with discussions about planetary missions, went eerily quiet. When a researcher from the Rosetta mission team posted a query asking why Mars Express had changed its observation plan to image the 3i Atlas trajectory corridor, her comment was deleted within hours. The official moderator cited off-topic content. Off-topic from what? The media caught hints but not the whole picture. A few outlets ran articles about temporary satellite maintenance, recycling NASA's talking points. But scattered across dark corners of the internet, independent astronomers began cross-checking data. They noticed gaps in the minor planet center updates, delays in brightness curves, missing data for entire observation nights. That doesn't happen naturally. It happens when someone throttles the data feed upstream. Meanwhile, inside a secure conference room in Washington, D.C., senior NASA administrators joined a video link with US Space Command. The topic line on the agenda read simply, Interagency Readiness Synchronization, Object 3I. The word Atlas didn't appear anywhere in the notes. Only the codename Object 3I. The meeting's classified summary, later referenced in a leak, described coordinated operational posture alignment across civilian and defense assets. Translation: NASA and the military were now treating the same celestial object as a shared concern. The decision to elevate that coordination didn't come from astronomers. It came from a joint review board operating under Presidential Directive 42B, the one that governs integrated space situational awareness. According to the directive, if an object displays potential anomalous energy signatures or dynamic behaviors inconsistent with established celestial models, it triggers an automatic interagency response, the catch. No public confirmation is required until the data crosses a specific threshold. We don't know what that threshold is. We only know that something crossed it. By the end of that week, the Deep Space Network's Canberra antenna array began transmitting narrowband pulses toward the approximate coordinates of 3I Atlas. Low power, high-frequency pings used to refine radar cross-section readings. But those pings can also serve another purpose, active probing, testing how a target reflects energy, how it interacts with directed signals. A technique developed not for comets, but for stealth satellites and re-entry vehicles. Publicly, NASA explained these transmissions as routine radar observations. Privately, several engineers involved in the process reported new encryption layers added to the data stream, encryption not used for normal science telemetry. They described it as like locking the door to your own lab before you start the experiment. When asked why, one of them replied off record, "Because we're not the only ones listening." Across the Pacific, China's National Space Science Center also shifted into overdrive. Their tracking facility in Xinjiang began conducting high-resolution spectroscopy of the comet's tail, though none of the results have been published. The timing matched the US escalation almost perfectly. Coincidence or parallel response? Either way, two global superpowers were suddenly watching the same supposedly harmless object with military precision. At the human level, within the scientific community, confusion spread. Researchers who had applied for telescope time to study 3I Atlas were informed their slots had been postponed due to coordination priorities. Those who already had data found their uploads delayed by system validation reviews. A few spoke publicly, cautiously, describing the environment as tense and unusually restrictive. Others went quiet altogether. In this new silence, theories multiplied. Some said the comet's infrared signature resembled that of a metallic object. Others claimed radio telescopes had picked up structured noise, periodic pulses in the microwave band inconsistent with natural plasma phenomena. Most of these reports remain unverified, but the mere suggestion was enough to ignite the imagination of a global audience already primed by years of mystery surrounding interstellar visitors. And then came the strangest signal of all, not from space, but from the agencies themselves. Overnight, several social media accounts belonging to NASA field centers were deactivated. Scheduled posts vanished. Outreach campaigns paused midstream. One post, briefly live before being deleted, contained only 2 words: operational silence. No one has explained that phrase. By the time dawn reached the continental United States, the synchronization was complete. The world's defense and observation systems were now, for the first time, behaving as one continuous network, a global instrument aimed at a single point in the sky. If 3I Atlas truly posed no threat, why build a response architecture fit for war? Outside, the comet moved on, unbothered. Inside, we had crossed a line without noticing, from observation to vigilance, from science to strategy. Somewhere between the data streams and the encrypted transmissions, Earth had quietly shifted its posture. Not defensive, not offensive, something in between, a silent readiness. And as the systems hummed in synchronization, a new question formed, whispered in control rooms and late-night labs alike. What did they see that we haven't yet been told? For weeks the sky had seemed calm, a dome of quiet stars, undisturbed, indifferent. But behind that calm, telescopes were moving like pieces on a chessboard. What had started as subtle adjustments had become a global choreography of precision. Telescopes in Chile, Spain, South Africa, Japan and Hawaii were all pointing toward the same patch of darkness trailing through Atlas. The world's eyes were repointed, but not everyone was allowed to see. Inside the European Southern Observatory, a quiet order circulated through encrypted internal channels. The subject line read simply, Restricted Observation Parameters, Atlas 3I. To the uninitiated, it looked procedural. To those who'd been through this before, the drills, the coordination exercises, it meant one thing, a data lockdown. Observations would continue, but access would be limited. Every image, every spectral readout, every timestamp would flow through a verification hub before release. Verification by whom? That part wasn't specified. Normally astronomy thrives on openness. Data sharing is its lifeblood. The cosmos is too vast for any single nation to study alone, and international cooperation has always been its quiet triumph. But something about 3I Atlas broke that tradition. Observatories that once published real-time logs began holding back. The Minor Planet Center, usually a hub of transparency, started publishing updates that looked strangely sanitized. Raw positional data replaced with summaries, emission readings truncated. The error margins were still there, but the context was gone. At first, the gaps were subtle. A few missing nights, an omitted dataset, a silence explained by bad weather or maintenance downtime. But soon the absences became patterned, a rhythm of omission that followed the comet's path as it moved away from the sun. When independent astronomers tried to correlate brightness variations from public archives, they discovered something impossible. The brightness curve of 3I Atlas showed minor fluctuations at precise 8-hour intervals, too regular to be random, too brief to be explained by natural rotation. When those anomalies reached online forums, NASA's official response was immediate and dismissive. Processing artifacts, they said. Camera noise. But the data came from multiple instruments across multiple continents, all showing the same rhythm. It wasn't noise, it was something repeating, structured, precise. A researcher at the University of Arizona, speaking anonymously, claimed that internal emails within the NASA Astrophysics Division referred to these fluctuations as periodic optical modulations, a term that never appeared in public-facing reports. In one email, dated October 23rd, a project scientist asked a simple, unnerving question. Could this be rotational beaconing? The message was flagged for internal review and subsequently deleted from the archive. Beaconing. The word lingered. It wasn't just optical data that raised eyebrows. Infrared readings from the James Webb Space Telescope showed intermittent spikes in thermal emission, localized bursts that appeared and vanished faster than typical outgassing events. Normally, cometary activity is gradual, driven by sublimation of ices as they heat under solar radiation. These bursts, however, were too sharp, too synchronized. Analysts tried to explain them away as venting from fractured surfaces, but one internal note compared the pattern to signal transients. At ground level, the pattern extended beyond NASA's facilities. The Indian Space Research Organization's new Deep Sky Tracking Array went off public feed for upgrades. Japan's Subaru telescope stopped uploading night logs. Even the independent Las Cumbres Observatory Network, a system built to democratize astronomy, began experiencing mysterious outages whenever 3I Atlas entered its viewing window. The coordination was too consistent to be coincidence. Observers who'd been denied access described an invisible hand reorganizing priorities. Telescope time, once determined by peer-reviewed proposals, was suddenly overridden by directives referencing international alignment with ION campaign parameters. But those campaign parameters weren't available for review. The only thing clear was the result. Global observatories all moving in synchrony, all gazing at a single object through a curtain of censorship. In Washington, the first whisper of the leak emerged. A file labeled DSC-12 appeared on a secure whistleblower portal, known for its record of accuracy. The document was incomplete. fragments of an internal memo referencing something called Deep Space Contingency 12. The partial text read, "Activation of DSC-12 requires synchronized observation of subject body using multispectrum instrumentation. Maintain data integrity and chain of custody for subsequent analysis under Tier 4 readiness framework. All participating observatories are to withhold public release pending joint clearance." No explanation, no signatures, just a date. October 17th, 3 days before the network synchronization began. For analysts familiar with planetary defense protocols, the implications were immediate. Tier 4 readiness was not scientific terminology, it was military. In the defense lexicon, Tier 4 corresponds to active monitoring of potential adversarial technology. Not asteroids, not comets, technology. When confronted, NASA's spokesperson dismissed the document as a fabrication, but the phrasing matched prior classified communication styles almost word for word. Within hours, online investigators traced the formatting to genuine internal documents from previous exercises. If the leak was fake, it was a masterwork of mimicry. If it was real, then NASA was now operating under a directive that treated 3I Atlas as a potential engineered object. Meanwhile, inside the Defense Science Board, satellite data was being cross-analyzed with optical readings. Multiple sources claim that sensors aboard the space-based infrared system, SPARES, had detected low-frequency emissions from the comet's general region, faint but structured. Not radio, not natural radiation, but something closer to modulation, an on-off pattern buried in the noise floor. These are the same systems designed to detect missile launches and nuclear detonations. For them to pick up anything at interplanetary distance is rare. For that signal to repeat is nearly impossible. The classified report describing those findings was titled Spectral Event 119b. Its conclusion, energy source consistent with non-thermal process, origin indeterminate, non-thermal. That phrase means not generated by heat or chemical reactions, the defining trait of all cometary emissions. In other words, something in or near 3I Atlas was producing energy by mechanisms we couldn't explain. Still, NASA's public face remained calm. In press briefings, officials emphasized scientific opportunity and global collaboration. They smiled for cameras, gestured toward the heavens, and spoke of curiosity, not caution. Yet behind them, the machinery of secrecy continued. Within the Jet Propulsion Laboratory, 2 departments, astrodynamics and mission systems, were now requiring mutual clearance for shared data. Researchers found themselves signing new non-disclosure agreements labelled Temporary Security Classifications. The message was clear. Talk less, observe more. Outside the institutional walls, the citizen science community started pushing back. Amateur astronomers began publishing their independent measurements, forming what they called the Open Atlas Network. They shared raw data across decentralized servers, comparing light curves and spectral readings in real time. For a brief moment, the flow of information surged again, until the network's central domain was suddenly hit with a denial-of-service attack, traced to an IP range belonging to a defense contractor. Coincidence? Possibly. But the timing matched perfectly with the internal escalation of DSC-12. As the blackout deepened, one figure spoke publicly. Dr. Lila Morrow, a systems engineer who had previously worked on NASA's DART mission, broke silence during a live-streamed interview. Her voice was calm, but her words cut deep. If 3I Atlas is harmless, why are we testing protocols written for hostile satellites? Why is every spectrometer being treated like a weapons sensor? The clip spread online before being swiftly removed from major platforms under vague misinformation flags. Within a day, her university email was deactivated, pending review. Something larger was unfolding, not panic, but preparation. In the United States, the Space Force increased the alert status of its orbital command assets. Not a full mobilization, but a readiness drill disguised as routine calibration. Satellites began entering low-noise standby, a configuration meant for coordinated tracking or defense exercises. The move was mirrored in Europe and Japan. Publicly, agencies cited solar interference. Privately, they synchronized their instruments to one shared timetable, the same 8-hour cycle that defined the comet's unexplained flicker. And yet amid the secrecy, a pattern of humanity persisted. Scientists still whispered their findings to each other through encrypted chats. Students still tracked the comet from backyards and rooftops. Somewhere in the tension between fear and fascination, a quiet determination took root. People wanted to know the truth, and not the official version. But for every piece of data revealed, 2 more vanished. By late October, even the open-access portions of NASA's PDS archive were showing metadata inconsistencies, gaps where file names once existed. Someone was rewriting the record in real time. What were they protecting us from? A misunderstanding? A panic? Or the realization that a harmless visitor might be something else entirely? Something that doesn't fit our categories of natural or artificial? Something that forces a redefinition of both? By the time the public noticed the missing data, the redirection was complete. The world's instruments were still watching, still recording, but no longer for science alone. They had become part of a new architecture, one built not for discovery but for control, and somewhere in the filtered noise, hidden beneath layers of encryption, was a signal still waiting to be understood. A whisper from an object the world keeps calling a comet, for now. It began quietly, as most real mobilizations do, not with a declaration, but with paperwork. A line buried deep in NASA's daily operations summary: asset prioritization, non-terrestrial observation. To the untrained eye, it looked like routine bureaucracy. To the few who knew what the phrase meant, it was a signal, the first administrative tremor before something larger moves. By October 23, 2025, only 2 days ago, the International Asteroid Warning Network had entered what insiders call silent coordination. The trigger wasn't an impact threat, but an instruction marked DSC-12, Deep Space Contingency Level 12. No public announcement, no press advisory, just an internal directive shared across encrypted channels linking NASA, the European Space Agency, and the United States Space Command. At 11 a.m. UTC that morning, NASA's Planetary Defense Coordination Office initiated Operation Meridian, a readiness test spanning civilian and military assets. Officially, the exercise was to validate data-sharing frameworks. Unofficially, it activated at least 24 satellites, redirecting sensors toward one moving coordinate near the orbit of Mars, 3I Atlas. Observers outside the loop first noticed the shift when 2 Spear satellites, normally used to detect ballistic missile launches, altered their orientation to a deep space track. The change was subtle but measurable in the telemetry. Within hours, analysts watching orbital behavior confirmed what they'd suspected. The world's early warning systems were being trained on something far beyond their usual targets. In Geneva, ESA mission planners were told to allocate continuous observation time for Object 3 Atlas, pending further instruction. No explanation followed. In Washington, a memo from the National Security Council authorized limited sharing of defense-grade tracking data with NASA. That clause, normally invoked during solar flare crises, was signed under the code word Meridian 4. Late on the night of October 23rd, amateur satellite trackers reported unusual burns from an unlisted payload leaving Vandenberg Space Force Base. The object climbed into a high-inclination orbit and vanished from public tracking within 2 passes. The following day, radar at Clear Air Force Station began transmitting on frequencies reserved for deep space calibration. The timing matched the launch window exactly. Inside NASA, scientists felt the change before they saw it. Meetings once open to project staff suddenly required new clearance levels. The planetary defense Slack channels went silent. Messages disappeared after being read. One engineer described it later. You could feel the air get heavy, like everyone knew something but didn't want to be the one to say it out loud. By October 24th, the mobilization was undeniable. The Deep Space Network's Canberra dish began transmitting short radar pulses toward 3I Atlas. Officially, the purpose was to refine astrometry. Off the record, several technicians noticed the pulses were patterned, frequency stepped in a way typically used to analyze material density, not orbital position. Within hours, those return echoes were encrypted and rerouted to a joint NASA Space Force server farm in Colorado Springs. Around the same time, ESA's Cluster 2 satellites switched from magnetospheric science mode to a configuration labeled Synchronized Telemetry Acquisition. Even private observatories felt the ripple. The Las Cumbres network's public dashboards went dark under temporary maintenance, and the European Southern Observatory, issued a 48-hour embargo on images that included 3i Atlas in frame. The press never connected the dots. A handful of reporters questioned the blackout, but NASA's answer was simple and effective. Routine recalibration during solar interference. The words did their job. Stories vanished by morning. Behind the curtain, however, coordination deepened. A closed-door video session joined senior figures from NASA, the Defense Intelligence Agency, and the Department of Energy's Los Alamos lab, institutions that rarely appear in the same meeting. The agenda leaked later. Assessment of non-thermal emission sources, interagency review. Non-thermal, that phrase again, energy that doesn't come from heat, energy from something else. That night, October 24th going into 25, data analysts at JPL detected a transient brightening of 3i Atlas by roughly 0.3 magnitudes. Not enough to spark headlines, but enough to matter. The increase occurred while the object was still behind the sun's limb, a time when direct sunlight shouldn't reach it. Within minutes, those readings were forwarded to the classified network under the DSC-12 header. Elsewhere, a parallel system reacted. The US Space Force's Orbital Control sent out a quiet status update. Tier 4 readiness achieved. In military language, Tier 4 is one step below activation. It doesn't mean engagement, it means expectation. By dawn on October 25th, the mobilization had spread globally. The European ground stations at Cebreros and Malag entered continuous observation mode. Japan's JAXA adjusted its deep space antennas to track the same coordinates. Even the Canadian radar network, primarily designed for auroral research, began capturing high-frequency returns from near the comet's projected path. No one publicly acknowledged the synchronization, but the timing was exact. Every few hours, instruments across continents blinked in perfect sequence, as though following an invisible conductor. Meanwhile, public communication grew strangely careful. NASA's latest statement, issued this morning, repeated the same 4 words used since July: no threat to Earth. But now the phrasing feels different, rehearsed, defensive. The agency no longer sounds like it's reassuring the world, it sounds like it's reassuring itself. In underground data forums, leaked snippets from defense contractors began circulating. One, verified by metadata, referred to a new coordination cell named Project Trident. Its purpose? To evaluate anomalies exhibiting structured energy profiles inconsistent with natural celestial sources. The wording doesn't say weapons. It doesn't have to. At this hour, October 25th, 2025, the mobilization continues. ESPER's satellites remain in deep space orientation. Radar arrays are locked to their targets. Every observatory capable of observing 3i Atlas is now part of a global network that behaves less like a research collaboration and more like an early warning grid. If the object is just ice and dust, why is the planet acting like it's under surveillance? Maybe because what they're seeing isn't danger, it's uncertainty. And uncertainty to institutions built on control feels indistinguishable from threat. Outside, the night sky looks unchanged. Inside command rooms across the world, the numbers flicker, the frequencies hum, and the quiet mobilization deepens, invisible, unspoken, undeniable. The world has moved from curiosity to caution, from observation to readiness, and still no one has said why. There are documents that exist in plain sight, visible, archived, cited in policy papers, and then there are those that hover just beyond reach. Deep Space Contingency 12 belongs to the second category. It was never meant to be spoken aloud, never meant to appear in news cycles or congressional hearings. Officially, it doesn't exist. But as of this week, fragments have begun to surface. Fragments that, when pieced together, tell a story the public was never supposed to hear. The first clue appeared late on October 24th, when an internal message from a NASA contractor leaked through an anonymous upload site used by journalists. The file name, DSC-12 readme.pdf. It was only 3 pages long, heavily redacted and unsigned. But the surviving lines were enough to cause tremors inside the agencies. Objective: establish unified protocols for the characterization and neutralization of deep space anomalies exhibiting structured energy emissions inconsistent with known natural phenomena. And another line even more unsettling: In the event of ambiguous or indeterminate origin, assume potential adversarial technology until proven otherwise. Those two sentences reframed everything. For decades, planetary defense was about asteroids, impacts, trajectories, deflection missions. But DSC-12 wasn't written for rocks, it was written for intent. It defined a new category, deep space anomalies, not threats of mass but of meaning, signals, behaviors, compositions that didn't fit the models. In short, 3I Atlas territory. Hours after the leak, NASA's public relations team released a statement dismissing it as fabricated. Yet within 12 hours, a near-identical phrase surfaced in an internal ESA memo obtained by Der Spiegel's science desk. Non-celestial anomaly protocols to remain active under DSC framework until object departs inner solar region. The wording was precise. The denial no longer held. Inside NASA, the atmosphere shifted from tight-lipped caution to something closer to controlled panic. Teams in the Planetary Defense Coordination Office were summoned to a weekend review session, Saturday, October 25th, under security classifications most had never encountered. Cell phones were surrendered at the door, network access was revoked. The meeting's agenda, later confirmed by two attendees, listed a single item: Object 3I, Operational Status Update. According to those present, the briefing didn't come from scientists. It came from an Air Force liaison attached to the Space Force's Orbital Command. He began with a chart showing the comet's light curve. The data was real, familiar, until he overlaid it with a new plot. Fluctuations in low-frequency radio noise recorded across multiple defense satellites. The two graphs matched perfectly. Each optical modulation coincided with a brief, patterned burst of electromagnetic energy. "This isn't random," he said. "It's structured." The room went still. For a moment no one spoke. Then one of the NASA analysts, a spectral physicist, asked the only question that mattered. Structured by what? No answer was given. The liaison simply advanced to the next slide, a classified clause from DSC-12 authorizing active response measures if a deep space object demonstrated coherent emissions exceeding baseline variance. What those measures were, he didn't say. But the implication was clear. NASA wasn't just observing anymore, it was authorized to act. That single word, response, marked a quiet turning point. It meant that planetary defense was no longer purely defensive. It was deterrence, built into the language of space science. The word neutralization in the directive wasn't rhetorical, it was operational. Within hours of that meeting, changes rippled outward. The Jet Propulsion Laboratory's Mission Operations Room locked down its remote access terminals. Scientists who'd been analyzing cometary spectra suddenly found their datasets flagged for export control compliance. And on NASA's internal collaboration server, a new channel appeared, unlisted, invitation only, titled Deterrence Architecture Review. The inclusion of that word confirmed the unthinkable. 3I Atlas had become part of a strategic framework, not a scientific campaign. Whatever the object was doing, someone high enough to sign classified authorizations had decided it could no longer be treated as benign. Publicly, everything remained calm. NASA issued cheerful updates about Mars rover soil samples. ESA tweeted a photo of Jupiter's aurora. The illusion of normalcy held. But beneath it, the agencies were behaving like a single organism under stress, retreating into silence, tightening their communications, aligning behind language crafted for control, not discovery. Then came a second leak, smaller but sharper. It originated from a European ground station technician who had been monitoring data synchronization logs. Hidden in the time-stamped metadata was a phrase that shouldn't have been there: engage Echo 1 asset for adaptive illumination test. Echo 1 isn't the name of a known telescope, probe or satellite. Some believe it's an internal code name for a classified payload, possibly a laser-based diagnostic array designed to project modulated pulses toward distant targets. Officially, such technology is still in development, but the metadata told a different story. The timestamp, October 25th, 04-16 UTC, matched a brief unexplained radio silence across the deep space network. For 12 minutes, every DSN dish, Goldstone, Madrid, Canberra, went dark. Not a technical fault, not a glitch, but a deliberate pause, and when they came back online, the first data packets contained abnormal phase offsets. The signature of an outbound signal, not a return. Someone had transmitted something. NASA has offered no comment. What then is Echo 1? A test pattern? A probe ping? Or the first active attempt to illuminate whatever 3i Atlas really is? The timing is too perfect to ignore. The DSC-12 directive authorises active measures only after confirmation of coherent emissions. Those emissions were confirmed less than 24 hours earlier. Coincidence or chain of command? Within the scientific community, the reactions have split sharply. Some argue this is overreach, the militarisation of an anomaly that should remain under open study. Others quietly admit they've seen the data and can't explain it. "It's not noise," said one researcher off record. "It's geometry. Geometry implies design. Design implies intent. And intent is what terrifies institutions built on the idea that nature is impersonal." By mid-afternoon, talk of Echo 1 had reached Capitol Hill. Congressional staffers requested briefings on deep space object contingencies. The request was denied on national security grounds. The White House press office declined to confirm or deny the existence of DSC-12. But a source close to the National Security Council described the mood in one word: uneasy. What happens next depends on what those classified systems see in the days ahead. If 3i Atlas behaves predictably, the directive may quietly dissolve. If it continues to emit structured signals, or worse, respond, the framework allows escalation to Phase 2 deterrence posture. No one outside the chain of command knows what that entails. But history tells us that once a protocol like this activates, it rarely deactivates completely. For now, the official stance remains steady. No threat, no concern, no cause for alarm. But beneath that calm language lies a new operational doctrine, one written not in press releases, but in the secret architecture of readiness. A doctrine that quietly redefines planetary defense not as a shield, but as a trigger. Because if the unknown can no longer be explained, the next instinct is to contain it. And containment, in the language of those who prepare for worst-case scenarios, always begins the same way, with a directive. One that says, assume nothing is natural until proven otherwise. By the morning of October 26th, the data didn't look like data anymore. It looked like language. If not a language we could read, then one written in the pulse of light and the rhythm of energy. Scientists describe it clinically: non-thermal emissions with structured periodicity. But stripped of jargon, it means something out there was blinking with intent. It started with radar returns from the Canberra Deep Space Network. When the Echo 1 illumination test pulsed outward, the one NASA refuses to confirm ever happened, the array recorded a faint but measurable reflection from the direction of 3i Atlas. Normally, radar scatter from a comet looks chaotic, like static from a rough mirror made of ice and dust. This reflection was different. The signal came back clean, narrow, banded, as if bouncing off something smooth. Not metallic, not necessarily artificial, but coherent. Engineers ran diagnostics. The instruments were fine. Atmospheric conditions were stable. Yet the return wave contained a phase shift pattern repeating every 46.8 seconds. That timing didn't match the radar pulse cadence. It was as if the Echo carried its own internal clock. The data was transmitted to NASA's Jet Propulsion Laboratory for analysis. There, algorithms broke it down into its spectral components, a sequence of low-frequency hums buried beneath noise. One of the interns working on the analysis, unaware of the classification level, reportedly asked, "Why does it look modulated?" The room went silent. Minutes later, that workstation was logged off remotely. The file was reclassified as operational telemetry. In science, operational telemetry is code for you don't need to know. Within hours, the Canberra anomaly was corroborated by independent data from the European Space Agency's Cebreros station. They too had detected a return echo, fainter but consistent. The phase pattern matched. It wasn't random. 2 hemispheres, same result. When cross-checked against optical readings, the timing aligned with a series of brightness pulses in the comet's coma, bursts too regular for outgassing jets. Light curves from October 25 to 26 show subtle surges every 47 seconds, perfectly matching the radar phase intervals. 2 different instruments, 2 different wavelengths, 1 rhythm. That rhythm became the center of everything. At first, scientists tried to fit it into natural models. Maybe it was rotational. caused by a tumbling nucleus exposing reflective surfaces. Maybe it was thermal cracking, periodic jets venting from internal pressure cycles. But every model broke on the same fact: the consistency. Natural cycles drift, they wobble. This one didn't. The pulses kept time like a metronome. An internal note from JPL's spectral analysis team marked restricted contained a chilling line. Amplitude modulation consistent with encoded repetition. Suggest further pattern correlation. Encoded repetition. Those words shouldn't exist in a Comet report. Meanwhile, the minor planet community, the outsiders, the amateurs, the independent observers, began noticing their data feeds lagging by hours. The Minor Planet Center's updates slowed to a crawl. Requests for raw photometry data returned empty. For the first time since the program's creation, global access to a tracked object was effectively severed. Publicly, NASA downplayed the blackout as server maintenance. Privately, it was something else. Each dataset had been routed through a classification filter known as Aurora, a program originally designed to scrub satellite imagery of sensitive orbital assets before public release. Now, Aurora was being used to censor astronomical data. Inside the Space Force's intelligence branch, the phrase Spectral Event 119b reappeared in briefings, the same designation first used during the October 23rd coordination meetings. But the new logs contained a startling addition. Observation confirms persistent periodic emission source associated with 3I Atlas. Amplitude modulation suggests non-random structure. Correlation with radar reflection indicates potential interaction with transmitted signal. Interaction. That word changed everything. If correct, it meant 3I Atlas wasn't just emitting energy, it was responding. The public never heard about this because within 12 hours the finding was absorbed into Project Trident's classified channel. The next day, the phrase energy coupling confirmed appeared in metadata of a defense communication log. No details, no context, just those two words. To some, it looked like the beginning of a discovery. To others, it looked like the start of something else, a test. Across the Pacific, Japan's Subaru telescope managed to capture a single high-resolution polarization image of 3I Atlas before its data stream was locked. In that image, faint linear streaks radiated outward from the nucleus, intersecting at consistent angles. The pattern looked geometric, almost symmetrical, like the spokes of a wheel. Analysts called it an artifact, a diffraction effect. But one physicist, speaking off record, offered another theory. Interference pattern, two sources, not one. Two sources, one comet, one unknown reflector. If the Echo 1 signal had indeed been transmitted, perhaps the return didn't come from the comet's surface at all. Perhaps it came from something near it. By now the language between agencies had shifted. The words object and comet appeared less frequently in internal memos. They were replaced with target and body. The tone had changed from curiosity to command. No one asked what it was anymore. The question had become how to manage it. Late on October 26th at 2241 UTC, the Deep Space Network recorded a final anomaly. A brief surge in background static across multiple frequencies. A kind of hiss that lasted exactly 47 seconds, then stopped. The signal was strong enough to overload several amplifiers. Afterward, systems auto-reset, as if nothing had happened. When the recordings were replayed later, one technician noted a faint oscillation in the waveform. 3 rising tones, evenly spaced. To the untrained ear, it was just noise. To someone who's spent a lifetime studying signals, it sounded uncomfortably deliberate. Meanwhile, inside NASA's communications hub, new instructions were issued to all field centers. Suspend further commentary regarding 3I Atlas observational data until official review completed. All external inquiries to be redirected to PDCO Public Affairs. Public Affairs meant silence. The agency wasn't going to lie, it simply wasn't going to speak, but silence can be measured too. The next day, amateur astronomers noticed that even NASA's live sky tracking dashboard had stopped updating the comet's coordinates. Its entry remained frozen, position data from 48 hours earlier. For an organization obsessed with precision, that kind of omission isn't an oversight, it's a decision. Within the community, whispers turned to dread. People began asking a question they'd been avoiding since July. What if it's not a comet at all? The pattern of reflection, the perfect rhythm, the consistent emission timing, none of it fits. Not physics as we know it. Not randomness as nature provides it. The object might not be hostile, might not even be active, but something about it behaves like it knows it's being watched. As one astrophysicist wrote anonymously in a forum post before it vanished, "We send signals into the dark hoping for a response. Maybe we got one, and we're not ready to admit it." Maybe that's why the data is vanishing. Not because it hides danger, but because it hides recognition. Because the worst discovery wouldn't be proof of threat, it would be proof of awareness, and awareness changes everything. By October 27th, the world was starting to notice. Not the details, not the radar returns, not the 47-second pulses, but the silence. The data drought had grown impossible to ignore. Astronomers accustomed to daily updates from NASA and the European Space Agency were staring at blank dashboards. The public feeds from the Minor Planet Center still displayed coordinates for 3i Atlas, but the timestamps hadn't changed in nearly 3 days. For an object moving through interplanetary space at over 60 kilometers per second, that kind of freeze is catastrophic for tracking. Officially, it was a technical backlog. In reality, it was the first coordinated cover story in modern astronomy. The first hint came from a press release drafted inside NASA's Communications Division on the evening of the 26th. It described a temporary data synchronization issue caused by redundant verification processes. The language was designed to sound boring, a linguistic sedative. But the metadata told another story. The release had gone through 6 rounds of revision, not by scientists but by policy advisors and 2 representatives from the Department of Defense's Office of Information Control. The final version removed any mention of radar studies, emission anomalies, or even the term spectral. It was reduced to a generic reassurance. All observations remain nominal. Nominal? The word bureaucracies use when they mean we can't explain it. The cover story spread fast. Within 12 hours, every partner agency adopted the same phrasing. ESA reposted NASA's message verbatim. JAXA issued a statement about data harmonization. The Indian Space Research Organisation went even simpler, tweeting only, "No deviation detected." That single sentence was retweeted 30,000 times, not because it was comforting, but because it sounded rehearsed. Meanwhile, beneath the smooth layer of official calm, confusion turned to fracture. Inside NASA, career scientists found themselves split into factions. The first, smaller group, the protocolists, accepted the lockdown. They'd seen the DSC-12 documents, read the clause about potential adversarial technology, and decided the safest course was compliance. The second group, the purists, resisted. For them, data was sacred. They began hoarding copies of raw telemetry before the servers purged it, swapping encrypted drives hand to hand like contraband. One of them, a photometry specialist in Pasadena, later told a colleague, "I've worked through eclipses, solar flares, everything. They've never scrubbed comet data before, not once." Within 24 hours of that remark, his access credentials were revoked. His badge failed at the door. He was temporarily reassigned to atmospheric calibration. In Washington, the tone hardened. An inter-agency memo circulated under the subject line, "Narrative Integrity, Public Interface." It outlined how press inquiries should be answered. No speculation. Reinforce scientific normalcy. Redirect all questions to planetary defense channels. Avoid the term signal. Use emission variability. In other words, rewrite reality until it sounds dull again. But outside the agencies, curiosity doesn't sleep. Amateur astronomers began stitching together their own light curves from independent telescopes, backyard instruments, university domes, even old military optics repurposed for citizen science. Their combined datasets told the same impossible story, a consistent 47-second modulation repeating across optical, infrared, and radio bands. On the 27th, an independent network calling itself the Open Atlas Collective published its findings on a mirrored server. The site crashed within an hour. When it reappeared, the dataset had been replaced with a single message: content removed in accordance with ITAR export regulations. ITAR, the law governing the export of defense-related technology. It was the first time that statute had ever been used to censor cometary data. For most people, the shift was invisible. The evening news spoke of a comet behaving normally, showing archival images from early October as if they were current. Science blogs recycled NASA's talking points. To the average viewer, nothing was wrong, but within scientific circles, panic bloomed quietly. A European researcher described the mood in a private email leaked later. "We are living in two realities, one for the cameras, one for ourselves." That divide deepened when a new internal report surfaced at the European Space Operations Centre. Classified for review, restricted, it analysed the radar reflections from the Echo 1 test. Its summary concluded, return signature indicates variable albedo consistent with high-density material, non-natural coherence observed across sequential pulses. Recommend cessation of active probing pending further directive, translated. They'd pinged something solid, something that answered back, and someone higher up had told them to stop. Yet NASA's next public bulletin, released the same day, stated the opposite. Radar tests yielded no significant return, object composition consistent with carbon-rich volatiles. The contradiction couldn't have been clearer. When the discrepancies reached journalists, NASA tightened the leash. Interview requests were funneled through a newly created email address, mediaresponse@nasa.gov, which, according to domain records, was managed not by NASA, but by a subcontractor tied to the Department of Homeland Security. The agency had effectively outsourced its voice. Inside the walls, morale collapsed. Scientists accustomed to open collaboration found themselves writing in code, speaking in half sentences, trusting no one. Coffee breaks turned into whispered strategy sessions. Everyone knew that emails were monitored. Some began using analog notebooks again, leaving them locked in desk drawers, a silent rebellion against digital oversight. Meanwhile, the world's attention was being redirected. The same weekend the data blackout peaked, NASA's communications arm launched a flood of unrelated announcements, an update on Mars rover soil chemistry, new exoplanet discoveries, even a feel-good story about students designing microsatellites. It was a distraction offensive, information as camouflage. The media took the bait. The comet vanished from the headlines overnight, but not from the networks that matter. Inside the Space Force's cyber intelligence branch, analysts were still dissecting the data. The term structured feedback loop appeared in an internal white paper marked Project Trident. The document proposed that 3I Atlas's emissions might not be spontaneous but reactive, modulating in response to directed energy input. The implication was staggering. The object might be listening. That idea, if leaked, would ignite panic or awe depending on one's faith in the unknown. So the cover story hardened further. NASA began scheduling interviews with familiar faces, trusted communicators, calm voices, who emphasized scientific skepticism. The talking points were uniform. Comets behave unpredictably. Outgassing can mimic signals. Coincidences are inevitable when analyzing large datasets, each sentence technically true. Each one concealing a larger truth. Outside, the amateur community turned defiant. They began mirroring telescope feeds across the dark web, using decentralized storage to escape takedowns. Some data was noisy, inconsistent, corrupted, but fragments survived. In those fragments, patterns persisted. The 47-second rhythm held. The purists inside NASA watched in silence, torn between loyalty and conscience. A few started leaking again, not documents this time, but phrases slipped into public databases. Tiny acts of defiance. In one otherwise routine update on orbital parameters, a single line appeared in the footnotes. Non-gravitational acceleration unresolved, further analysis pending. Those words, non-gravitational acceleration, were enough. Within hours, speculation exploded online. Bloggers resurrected comparisons to Oumuamua, the first interstellar object ever detected. "It's happening again," one headline read. "The comet that won't behave." NASA responded swiftly, amending the entry and deleting the note. But the damage was done. The story had escaped containment, and still, the emissions continued. As the 27th bled into the 28th, the Deep Space Network logged another anomaly, a brief phase inversion in the radar echoes, as if the target had altered its reflective properties mid-observation. To the engineers, it looked like interference. To the physicists, it looked like intent. By dawn, the directive from DSC-12 was clear. Suspend active illumination until further review. All subsequent observations passive only. In other words, stop talking, listen. But the real conversation had already shifted, from instruments to ideology. What does defense mean when the thing you're defending against might be watching you back? What is peaceful use of space when silence becomes the loudest weapon? The civilian cover story continues to hold for now. Most of the world still believes 3I Atlas is a harmless comet. Maybe that's true. Maybe the signals are coincidence, the reflections illusions. But if they're not, if the object is aware, even dimly, of the attention it's receiving, then the real story isn't in the data. It's in our reaction. Because every act of secrecy, every carefully worded denial, every shuttered telescope tells a simple truth about humanity. We are more afraid of confirmation than we are of danger, and if 3 Atlas is listening, that fear is the first thing it has learned about us. By the end of October 2025, the words planetary defense no longer meant what they used to. For years it had been a term of optimism, proof that humanity could work together against natural threats. Now it meant something else. Command chains, encrypted frequencies, classified payloads. The language of defense had quietly become the language of deterrence, and 3I Atlas was the test case. It began, as such things often do, with budget language, a routine appropriation request to the US Congress for expedited satellite calibration. Hidden in the fine print was a new line item, adaptive directed energy payloads for planetary hazard characterization. The phrase sounded scientific, but every defense analyst who read it recognized the euphemism: directed energy, lasers, tools that could, in theory, nudge a comet's orbit, or blind an adversary's satellite. No one outside a handful of oversight committees knew that these systems were already in orbit. 2 platforms, codenamed Sentinel-3 and Caduceus, launched from Vandenberg and Guam under the guise of deep space tracking demonstrators. In reality, they carried precision optical arrays capable of coherent light projection across millions of kilometers. Ostensibly, their purpose was scientific, to test how laser pulses could reveal a comet's composition. But the same hardware, reprogrammed, could deliver energy bursts strong enough to disable a small spacecraft. And as of October 28th, both were trained on 3I Atlas. Inside the Space Force's Orbital Command Center at Schriever, the feeds came in silently. Infrared sweeps, rangefinder data, telemetry from Caduceus showing successful beam convergence at interplanetary distance. A test, they called it. Calibration. But everyone in the room knew the implications. A laser that could map a comet could target anything. NASA's official role was passive. At least that's what the public believed. In reality, the agency's Jet Propulsion Laboratory supplied the targeting coordinates. The justification? Scientific alignment. Behind closed doors, an internal memo described the activity more bluntly. Engage directed optical emission for surface response analysis. Objective: assess energy coupling characteristics under controlled amplitude. Energy coupling. The same phrase that had appeared in Project Trident's reports days earlier. The same phrase used to describe how 3I Atlas had apparently answered the Echo 1 pulse. If the object really was reactive, then each test risked escalation, and yet they kept testing. Across the Atlantic, the European Space Agency initiated its own parallel operation, Project Helios, a joint experiment with the French Defense Ministry using adaptive ground-based lasers to assist in atmospheric calibration. The timing was identical to the US operations. The target, though unnamed, matched 3I Atlas's coordinates exactly. Even the Chinese National Space Administration joined the pattern, announcing an unscheduled high-energy LIDAR experiment at its Nari Observatory in Tibet. The public explanation spoke of lunar mapping. The beam path pointed nowhere near the moon. By then, at least 5 nations had aimed coherent light at a supposedly harmless comet, not to communicate, not to observe. To see what would happen when they touched it, and something did happen. At 03:14 UTC on October 28th, the Space Force's early warning satellites recorded a brief infrared spike from 3I Atlas, short, sharp, directional. The energy signature was weak but geometrically perfect. A straight-line emission, not a diffuse flare. It lasted 2.6 seconds. Then silence. The data circulated through encrypted channels under the header Optical Return Event. NASA called it thermal venting. Defense analysts called it something else. Coherent backscatter. In plain terms, a flash that looked like a reply. If the emission was natural, it was a cosmic coincidence of breathtaking precision, timed within minutes of an experimental pulse from Earth. If it wasn't, then humanity had just performed the first two-way interaction with something not built by us. But that's not the story the public heard. Within hours, NASA released an update titled Comet 3I Atlas Exhibits Standard Outgassing Behavior. The release included an image, low resolution, indistinct, suspiciously cropped. A handful of astronomers pointed out that the comet's tail appeared misaligned with solar wind direction. Their posts were deleted. The official caption read, "All activity consistent with cometary dynamics." Behind the facade, a different narrative took hold. Defense briefings began referring to engagement windows instead of observation periods. The National Reconnaissance Office requested funding for orbital illumination assets. The distinction between telescope and weapon was dissolving faster than anyone wanted to admit. The rationale was simple. If we could probe a comet, we could deter anything else that wandered too close. 3I Atlas had become a justification for building the next layer of the global shield. Politicians called it prudence. Physicists called it paranoia. At the Pentagon, a closed-door meeting between senior defense officials and NASA administrators produced a new directive, Strategic Optical Readiness Posture, SORP. It authorized temporary coordination between civilian observatories and military command centers during high-uncertainty celestial events. The directive's language blurred the boundaries between science and security entirely. From that day forward, the telescopes themselves became part of the arsenal. Inside NASA, not everyone agreed. Some scientists protested, arguing that using active illumination against an unverified target violated international space law. One of them, a systems engineer at Goddard, refused to sign off on the energy calibration. Her clearance was revoked within 24 hours. Her name disappeared from internal directories, yet the work continued. Each test produced new data, new justification. The returns from 3 Atlas showed faint polarization shifts, subtle enough to claim as scientific discovery, but structured enough to feed paranoia. A pattern began forming in the classified reports. When Earth emitted, the object responded. When Earth stayed quiet, the emissions faded. It was, by any rational metric, interaction. By the final week of October, the United Nations Committee on the Peaceful Uses of Outer Space had requested an urgent briefing. The US delegation declined to share data, citing national security classification. The meeting ended with no resolution. Meanwhile, defense contractors raced ahead. Northrop Grumman unveiled a concept for spectral defense arrays, small satellites capable of projecting coordinated laser grids for comet characterization. Lockheed Martin proposed active response platforms for orbital anomaly engagement. The phrases were designed to pass congressional scrutiny, but the subtext was clear. Space defense had found its Manhattan Project. In the media, none of this existed. NASA filled the silence with stories about education grants and asteroid mining. The word 3I Atlas vanished from press releases entirely, but the pattern of classified launches told another story. The same week, 2 new payloads lifted off from Cape Canaveral and Tanegashima under Space Situational Awareness missions. Their true names were redacted. Their orbits placed them directly above the ecliptic plane, ideal vantage points for observing the object everyone was pretending to ignore. And in all of this, one truth remained constant. No one could explain the 47-second signal. Publicly, NASA denied its existence. Privately, analysts continued tracking it. The pulses hadn't stopped. They'd merely shifted frequency, fainter, faster, as if adapting. When the directed energy tests ceased on the 28th, the emissions slowed to every 62 seconds. The object seemed to breathe. If it was reacting to us, then each laser pulse, each attempt to characterize, might be seen as an act of aggression. If it wasn't, then we were militarizing the cosmos over a misunderstanding. Both possibilities were terrifying. In one classified briefing, a Space Force colonel reportedly said, "It's not about what it is, it's about what it makes us do." He was right. The object's nature mattered less than our response. 3 Atlas had become a mirror, reflecting the deep-seated fear that the next frontier might not belong entirely to us. Across the world, telescopes glowed with covert light. Satellites hummed in orbit. The global shield stretched itself taut, ready for an impact that would never come, or a signal that might. Humanity had weaponized curiosity. The comet continued its flight, indifferent to our noise, our fear, our readiness. But from Earth, it no longer looked like a visitor. It looked like an adversary. And somewhere, buried deep in classified data streams, was a line that no one outside the highest clearance has seen. Emission frequency shift detected following directed energy exposure. Correlation 1.0, please 0.02. Perfect correlation. Maybe it was physics. Maybe it was response. Either way, it was enough for the next order to be written, the one that would blur the last distinction between telescope and target. And above us, the sky, once humanity's window into wonder, had quietly become a battlefield no one would ever admit existed. Every generation of scientists thinks it's the first to live at the edge of the unknown, but the truth is, the machinery of secrecy that surrounds 3i Atlas didn't appear overnight. It has lineage, it has precedent. Every command now echoing through NASA's servers and every encryption key guarding Project Trident traces its ancestry back to moments when the world first realized that the sky could hold both wonder and war. The pattern began long before this comet arrived. You can see its fingerprints in the classified footnotes of history, buried beneath acronyms, sanitized reports, denials polished to bureaucratic perfection. Every time humanity has stared too deeply into space, the same reflexes followed. Weaponize what you can't explain. In the 1960s, the Corona satellites were launched as geodetic survey tools. They were spy cameras pointed downward. In the 1980s, the Strategic Defense Initiative, the so-called Star Wars program, was sold as a shield against nuclear missiles. Its secondary goal, buried in congressional language, was spaceborne observation and countermeasure. Observation meant surveillance. Countermeasure meant weaponization. When the program faltered, its research quietly bled into NASA's optics division. The hardware became civilian. The philosophy did not. And now, in 2025, that same instinct has reawakened. The 3i Atlas mobilization, the activation of satellites, the classified launches, the directed energy tests didn't come from nowhere. It fits the architecture of a drill. Not a scientific campaign, not a defense exercise, but something in between. A real event used to test the response to a hypothetical one. And in that ambiguity, history repeats itself. Inside the Space Force archives, there's a series of documents known only by their designation, Operation Sentinel 2019 to 2021. Most of the files remain redacted, but leaked fragments describe live scenario readiness testing involving non-standard orbital anomalies. The goal was simple: simulate an unpredictable object, observe the response chain, refine protocols for space domain awareness. One entry describes a false target inserted into deep space radar streams, a phantom designed to test how quickly civilian observatories would coordinate with military assets. The lessons from that exercise directly shaped the protocols now being used under DSC-12. The difference is that this time, the target isn't false. When the comet appeared, the machinery already existed. Every relay, every encrypted handshake, every emergency clause in planetary defense charters, they were all relics of past rehearsals waiting for something to activate them. 3i Atlas merely provided the spark, and the similarities are uncanny. The same project codes, the same committee chairs, even the same phrases in the directives. Adaptive readiness posture, cross-domain illumination, non-gravitational anomaly tracking. These aren't coincidences, they're copy-paste inheritance. What was once a test has become doctrine. Consider the timing. The Echo 1 illumination test happened just days after a scheduled multi-agency readiness evaluation, a dry run planned months earlier. When the comet's anomalies emerged, the test became reality. The networks were already connected, the operators already trained, the satellites already primed. All that was missing was the justification. 3i Atlas provided it, like an actor stepping into a role written long before it was cast. In this light, the global mobilization looks less like panic and more like choreography, a sequence rehearsed so often that when the curtain finally rose, no one had to give the cue. The systems knew their lines. Publicly, NASA insists that no such drills exist. But internal memos tell a different story. One, from 2022, obtained by a European journalist before being scrubbed from the archive, describes a planetary defense integration rehearsal using a simulated interstellar object. The exercise was codenamed Stavros, and its hypothetical scenario involved unexpected energy emissions inconsistent with natural bodies. The conclusion of that report reads like prophecy. Future responses to anomalous interstellar detections must balance scientific transparency with operational readiness. Dual-track communication strategies recommended. Dual-track communication. In plain terms, one story for the public, another for those cleared to know more. That sentence, written 3 years ago, is the skeleton of the current cover story. 3i Atlas isn't just a discovery, it's the continuation of an unspoken rehearsal that never ended. The European Space Agency followed a similar trajectory. After the 2022 DART mission successfully deflected an asteroid, European officials proposed their own program, HERA, to study the impact site. But behind closed doors, defense committees in Brussels discussed expanding HERA's mandate to dual-use testing of kinetic redirection technologies. The documents were never declassified. The technology, however, was built. The coordination protocols, shared data channels, encrypted telemetry, joint observation schedules were tested in small exercises throughout 2023 and 2024. The same systems that tracked DART's target are now watching 3i Atlas. Even the global cooperation language is recycled. The press releases, the talking points, the soothing repetition of no threat to Earth. They mirror the phrasing used during Operation Sentinel when the test object didn't exist. Back then, the lie was a drill. Now the truth is disguised as one. It's not hard to see why. Every time a cosmic anomaly emerges, institutions face the same dilemma: admit uncertainty and risk panic, or impose secrecy and risk distrust. History shows which path they choose. In 2017, when Oumuamua displayed its unexplained acceleration, the world was told it was a rock. In 2019, when 2i Borisov entered the solar system, they said it was a comet. Now, in 2025, with 3i Atlas defying both categories, the narrative has simply evolved. It's a rock again, just one worth aiming lasers at. What the public doesn't know is that many of the instruments now studying 3i Atlas weren't built for comets at all. They were originally designed for orbital defense drills, proof-of-concept systems to track and characterize unidentified high-altitude phenomena. The very tools meant to investigate UFOs are now pointed at something that technically fits the same description, only larger, older, and moving through the solar system, and maybe that's why the pattern feels so familiar. Every few decades, a new phenomenon triggers the same cycle: secrecy, speculation, control. The names change, the reflex does not. During the Cold War, the sky belonged to generals. In the early 2000s, it belonged to surveillance agencies. Now it belongs to committees that speak the language of science, but operate under the logic of containment. One scientist who participated in both the DART mission and the current campaign described the déjà vu perfectly. Every time they call it a test, it's because they've already decided how it ends. But 3i Atlas refuses to follow the script. The emissions persist, the radar echoes continue. The object does not break apart or fade as expected. It endures, steady, cold, and silent. As though watching the watchers, each new test produces another anomaly, another reason to escalate, another justification to expand the shield. And in that cycle of reaction, humanity is learning something uncomfortable about itself. The drills have become reflexes, the reflexes have become doctrine, and the doctrine now operates without needing cause. A comet arrives, the world prepares for war, and no one remembers when readiness turned into habit. The cover story still stands, its language precise and practiced. NASA repeats, no threat to Earth. ESA echoes, scientific opportunity. The media repeats the refrain. But within the classified corridors where drills and reality have merged, a different phrase circulates. A quiet acknowledgement passed between engineers and officers. The rehearsal never stopped. If they're right, then 3i Atlas isn't the beginning of something new. It's the continuation of something ancient in human nature. the inability to witness the unknown without turning it into a battlefield. And somewhere in the void between stars the object keeps moving, calm, unhurried, untouched by the noise of those who fear it. Maybe it knows this was never really about it at all. Maybe the echo we've been hearing all along is our own. By the first hours of October 29th, the walls inside NASA no longer felt like walls. They felt like borders between two worlds that shared the same building but not the same purpose. One was scientific, bound by curiosity and evidence. The other was operational, bound by classification and command. The problem was that both sides needed each other. Without the scientists, the data meant nothing. Without the officers, the data never left the room. The split had been forming since the start of the 3i Atlas campaign, but now it was visible. The hallways at the Jet Propulsion Laboratory were lined with new security checkpoints. Swipe badges that once opened everything now flashed red. Access logs were audited hourly. Even cafeteria seating seemed to sort itself into two camps. The mission scientists on one side, the defense liaisons on the other, eating in silence. The directive known as DSC-12 had officially redefined planetary defense as a matter of national security, but its implementation fractured NASA's culture to its core. The agency that had once prided itself on transparency and global collaboration was now speaking a dialect of secrecy borrowed from the military. Words like classified, controlled, and need to know began to replace peer review and open data. Inside that tension, leaks became inevitable. The first came from within the astrometry group, the team responsible for calculating 3i Atlas's exact trajectory. A junior analyst found that her orbital model, which had shown a stable hyperbolic path, was overwritten overnight with new parameters that introduced a minuscule but persistent inward drift. The change was small, 1/100th of a degree, but enough to alter the long-term projection. The justification, uncertainty mitigation. The reality, someone had tampered with the record. She printed both versions side by side and sent them to a colleague at the Minor Planet Center. 2 days later, the colleague's access credentials were revoked, and his database mirror was wiped. The analyst never returned to work. Her badge stopped scanning. Her name was quietly removed from internal rosters. At Langley Research Center, a propulsion specialist noticed something even stranger. A classified server that had once stored DART mission telemetry now held a folder labeled Project Trident Phase 2. Inside were documents describing optical response contingency, including thresholds for non-hostile engagement. The wording was careful but unmistakable. The agency had drafted rules for contact, not impact avoidance, contact. He tried to raise the issue with his supervisor. The next day, he was placed on leave pending psychological evaluation. Word of these incidents spread fast. Fear turned to frustration. Conversations in hallways stopped when unfamiliar badges walked by. Scientists began using paper memos again, handwritten notes exchanged in code. Some used the names of constellations to refer to classified programs. Orion meant JPL. Cassiopeia meant the Pentagon. Trident meant everything no one wanted to admit was real. In late October, a small group of mid-level scientists met off-site at a coffee shop near Pasadena. There were 7 of them, 5 from NASA, 1 from ESA, 1 from the SETI Institute. They met under the pretense of discussing data calibration, but everyone knew why they were really there. One of them had seen the raw telemetry from the radar reflections. One had a copy of the optical modulation sequence, and one, the SETI liaison, had quietly run the pattern through an old algorithm used for detecting narrowband radio signals. It wasn't a message, not in any language or modulation we'd recognize, but it wasn't noise either. The program flagged the signal as structured. They didn't call it communication, they called it behavior. That night, one of the 7 posted a single line on a private astronomy forum. The object is behaving. It stayed online for 43 minutes before deletion. By morning, the meeting was known. Surveillance footage from the coffee shop appeared in an internal security briefing. The participants were warned against unsanctioned collaboration. One of them, a planetary geologist from ESA, resigned. The rest went silent. The divide had become open rebellion. At headquarters in Washington, the senior administrators held a closed meeting to address the information integrity crisis. The room split evenly between two factions. The scientists argued for a controlled disclosure, release the emission data, acknowledge the anomalies, let the global community verify the findings. The defense contingent argued the opposite. Premature disclosure could compromise observational security and inspire destabilizing narratives. In plain English, panic. The debate lasted 6 hours. At the end, the security bloc won. The vote wasn't unanimous, but the result was binding. Effective immediately, any discussion of non-gravitational anomalies would require clearance from the newly formed Planetary Defense Security Council, an interagency body reporting directly to the National Security Advisor. That's when the resignations began. A senior spectroscopist at Goddard quit after 30 years, leaving a one-sentence note. I signed up to study the stars, not to censor them. Another, an optical engineer in Madrid, uploaded her entire dataset to a public academic server just hours before her account was locked. The file was downloaded 30,000 times before being removed. The copies are still circulating in encrypted archives around the world. The leaks ignited a slow-motion rebellion within the scientific community. The Open Atlas Collective resurfaced, now operating entirely on the dark web. They published mirrored repositories of spectral data, anonymous interviews, and redacted excerpts from DSC-12. Their most chilling claim, that 3i Atlas had changed trajectory slightly in response to Earth's directed energy tests. The proof, a sequence of positional measurements matching the calibration burst from Sentinel-3. If true, it meant the object wasn't just reactive, it was navigating. NASA dismissed the claim as interpretative overreach, but privately one administrator admitted, "We don't know anymore what's signal and what's consequence." Meanwhile, inside the Pentagon, the mood shifted from scientific curiosity to strategic opportunity. Project Trident moved to Phase 3. The phrase orbital readiness appeared in meeting notes. Defense contractors were invited to propose rapid response intercept systems. The official justification remained planetary defense. The reality was that the anomaly had given the military exactly what it needed. A pretext to fund space-based weaponry without calling it that. For many inside NASA, that was the breaking point. They had built instruments to study the universe, not to militarize it. But the agency no longer controlled its own tools. The telescopes were now assets. The data was now classified. The scientists were now liabilities. One internal memo captured the despair perfectly. "We are watching the birth of a military branch disguised as a scientific discipline. The object doesn't scare me. Our reaction does." Outside, the public narrative held steady. NASA spokespeople smiled on camera, talking about Mars samples and lunar habitats. The words 3i Atlas barely appeared, but inside every observatory, every lab, every encrypted channel, the same whisper circulated, an unspoken acknowledgement that something fundamental had changed. Science had split into two realities, one where the unknown was meant to be studied, and one where it was meant to be contained. The fracture grew until even the most loyal staff began to question the purpose of their work. One engineer described looking up at the night sky after a 14-hour shift and realizing he no longer felt wonder, only suspicion. "It used to be exploration," he said. "Now it feels like surveillance." By Halloween week, internal communications at NASA included a phrase never before used in the agency's history: operational compartmentalization. It meant no one had the full picture anymore. Each division saw only fragments of the truth. The spectroscopists didn't know the radar data. The radar teams didn't know the orbital models. The modelers weren't told about the directed energy tests. Knowledge itself had become a controlled substance. And yet, somewhere inside that silence, conscience flickered. A handful of scientists began archiving everything: emails, logs, raw telemetry, on encrypted drives, quietly building a parallel record of what really happened. They called it the Second Archive. Its purpose wasn't to leak, not yet. It was to remember, because they knew how this story would end if they didn't. All the warning signs were there: the secrecy, the denials, the fear of transparency disguised as national security. It was the same script history had written 100 times before, only the setting had changed, from Cold War bunkers to space-age laboratories. And through it all, 3 Atlas continued its slow, silent arc away from the sun. The instruments kept tracking, the pulses kept coming, and the people trapped between truth and authority kept choosing which version of reality they were willing to live with. Some chose obedience, some chose exile, and a few, those building the second archive, chose legacy. Because they understood that one day when the comet was gone and the denials had hardened into myth, someone would need to know what really happened when humanity's curiosity met its own reflection, and what it cost to look away. By early November 2025, the mobilization around 3I Atlas no longer looked like a scientific investigation. It looked like a war game, one so elaborate, so synchronized, that the line between readiness and rehearsal vanished. Officially, every agency called it a coordinated observation campaign. Unofficially, it was something else entirely. The first full-scale test of the planet's defense infrastructure under real cosmic conditions. To the public, 3I Atlas remained a curiosity, a comet, a speck of light, a talking point for late-night science shows. But in command centers from Colorado Springs to Toulouse, it had become a scenario, a live target in a live exercise. The transformation began subtly. Internal memos started using phrases that didn't belong in astronomy: engagement windows, target tracking, system latency. NASA's mission briefings, once hosted by scientists, were now chaired by defense liaisons, and every piece of new data, every radar echo, every emission spike, every optical anomaly was treated not as discovery, but as validation. Proof that the protocols worked. It was as though humanity had been waiting for something like 3 Atlas just to see if it could. The concept wasn't new. The International Asteroid Warning Network had conducted simulations before, controlled rehearsals designed to test coordination during hypothetical threats. But those drills had always been declared publicly. This one wasn't. This one was invisible. Within the classified structure of DSC-12, the rehearsal was known as Project Meridian Continuity, an adaptive response simulation using live celestial stimuli. Its goal was deceptively simple: test how planetary defense systems responded to real-time anomalies. The exercise had no announced end date. The comet, unknowingly or not, had become the test subject. Across allied nations, the choreography was perfect. The European Space Agency's Helios laser program coordinated illumination bursts with US Sentinel satellites. Data sharing between Japan, India, and Australia was automated through encrypted orbital relays. The response timing, the handshake latency, was logged and analyzed in real time. The numbers were excellent. For the first time, the machinery of global defense operated as one, but the more efficiently the machine worked, the more detached it became from its stated purpose. A scientist at JPL described the eerie shift in tone during a classified briefing. They weren't asking what the data meant, she said. They were asking how fast we could deliver it. Her team wasn't interpreting observations anymore. They were measuring response times. Science had become metrics. It was during one of these metrics sessions that something unprecedented occurred. At 0127 UTC on November 1st, multiple ground-based sensors detected a fluctuation in the object's infrared emissions, a pulse that matched precisely the frequency of Earth's radar transmissions. The team logged it, analyzed it, and confirmed the correlation, but instead of publishing the result, the finding was forwarded to the Pentagon's Strategic Operations Command under the label Live Return Event. No one outside those networks knows what decision followed. Hours later, the Echo 1 relay, the same system responsible for the first radar ping in October, broadcast a low-power signal toward 3I Atlas. Officially, it was to validate communication stability, but internal correspondence between defense contractors called it a feedback test. The difference is subtle but important. Communication validation checks transmission reliability. Feedback tests check for acknowledgement. When the return signal arrived, a faint phase-modulated echo delayed by exactly 47 seconds, the room went silent. The timing was too perfect. 47 seconds, the same interval as the comet's original emission pattern. The coincidence was impossible to ignore. Engineers ran simulations, checked for sideband noise, replayed the raw feed. The signal persisted. No one called it a reply, but no one could call it random either. Within hours, the phrase mutual resonance event appeared in Project Trident's classified logs. The definition: a repeating energy correspondence between transmitted and reflected signals of unknown mechanism. To the scientists it was data. To the military, it was a test result, and the test had succeeded. From that moment, the global defense network transitioned from observation to operation. The rehearsal had become real. The next step was coordination. Space Command issued a new directive under the codename ORB-FIRE, Orbital Response Baseline, Field Integration Readiness Exercise. Every Allied agency received instructions to maintain synchronized deep space surveillance for 72 continuous hours. The objective: evaluate cross-system response to anomalous celestial behavior. But there was a darker layer beneath the exercise, the contingency clauses written into DESI 12 months earlier. One of them authorized preemptive orbital deterrence measures if non-terrestrial phenomena exhibit structured reciprocity. Structured reciprocity meant reaction. Reaction meant potential intent. Intent meant justification. And so, the network waited. Across the world, radar arrays hummed in unison. The telescopes were silent, their cameras covered, their images embargoed. Only the classified sensors watched, collecting terabytes of encrypted telemetry every hour. Each signal was time-stamped, processed, and fed into machine learning systems designed to predict adversarial orbital trajectories. Those models were originally trained on missile data. Now they were watching a comet. At Shriver, a senior officer reportedly asked the question that hung over the entire operation. If it responds again, what do we do? The answer came not from a scientist, but from a colonel overseeing satellite operations. Same thing we do with any unidentified aerial event. Record, escalate, and prepare for deterrence. Deterrence. The word echoed through every hallway, every secure server, every briefing. It no longer meant defending Earth from a rock. It meant preparing to confront an unknown intelligence in interstellar space. The irony, of course, was that there was still no proof of intelligence, only behavior, only correlation. Only the suggestion of awareness that everyone feared acknowledging. But in the absence of certainty, fear fills the vacuum, and fear justifies everything. As the days passed, the network's performance was analysed like a military operation. Reports evaluated latency, coordination, and decision readiness. NASA's role was reduced to a data conduit. The scientists' names were stripped from their own papers, replaced by project codes. Every anomaly became an opportunity to test another layer of infrastructure. At the United Nations, the US delegation quietly blocked a proposal for international transparency in planetary defense operations. The justification: sensitive technical overlap with national security frameworks. Translation: the rehearsal must continue. In Paris, the European Space Policy Institute held a closed-door symposium titled The Merging Frontier, Science and Deterrence. The keynote speaker, a retired general turned consultant, summarized the new paradigm succinctly. Every observation is an act of positioning, every telescope is a potential weapon, and every unknown object is an excuse to prove the system works. The attendees applauded. The system was working perfectly, smoothly, efficiently. Humanity had built a machine capable of coordinating global response to a cosmic event within minutes. The data pipelines functioned flawlessly. The command chains held. The protocols activated exactly as designed. But somewhere in that perfection, something essential was lost. In the haste to simulate defense, the idea of discovery died quietly. The comet was no longer a mystery to be studied. It was a scenario to be managed, an opportunity to test readiness. And the people running the tests forgot what it meant to look up and wonder. A physicist from ESA put it best in her resignation email. We've turned the night sky into a mirror reflecting our own fears. The drills are over. The theatre remains. By mid-November, the rehearsal had become indistinguishable from policy. The world's telescopes were now permanent nodes in a planetary surveillance grid. Every signal from deep space, every anomaly, every flicker of uncertainty would trigger the same choreography of secrecy and response. 3 Atlas had merely provided the proof of concept. In the final classified summary of Project Meridian continuity, one line stands out, a line that might one day be quoted in history books. If history still cares to remember, objective achieved. Coordinated planetary response executed under live conditions. System readiness confirmed. There was no mention of the comet's behavior, no acknowledgement of the emissions, no reference to the 47-second rhythm that started it all. The only metric that mattered was control. The rehearsal had worked. But in mastering the choreography, humanity had learned a dangerous lesson, that it could simulate a crisis so completely it no longer needed the real thing. And somewhere, far beyond the reach of its own transmissions, 3i Atlas kept moving through the dark, untouched, unbothered, unaware that it had just trained an entire planet to respond to the universe like a threat. Every story that feels new has already been written somewhere in the margins of history. The world looks at 3i Atlas and sees a singular anomaly, an event without precedent. But the cosmos remembers differently. For the universe, this is routine. For us, it's the same chapter replaying with a new name. The first interstellar visitor we ever recognized, Oumuamua, arrived in 2017, silent, small, and strangely fast. At the time, astronomers called it a cigar-shaped rock. Others called it something else, its acceleration, its brightness, its absence of dust. All wrong for a comet, too deliberate for debris. The scientific consensus insisted on natural causes, but consensus is often another word for comfort. When Harvard's Avi Loeb suggested Oumuamua might be technological, perhaps a fragment of an ancient probe, he was mocked, then ignored. 6 years later, his hypothesis reads less like fantasy and more like foreshadowing. Then came 2i Borisov, a proper comet with a tail, a reprieve from discomfort. It behaved as expected, confirming that the universe could still be ordinary. Scientists exhaled, told themselves that Oumuamua was a glitch in the pattern. Then 3i Atlas appeared, and the pattern returned. The same defiance of models, the same chemical impossibilities, the same sense that we're watching something that knows it's being watched. But 3i Atlas differs in one crucial way. It arrived after we built the machinery to respond. Oumuamua came when our telescopes were passive eyes. 3i Atlas came when those eyes had been wired into weapons. Across the decades, you can trace the repetition, the way every generation discovers its own version of the unexplainable, and then, instead of understanding it, builds new armor. In 1954, mysterious radar blips over Washington forced the US Air Force to scramble jets and invent a phrase, unidentified aerial phenomena. The same data today would trigger planetary defense protocols. We've replaced airspace with orbital space, but the reflex is identical. History's first interstellar object may have been recorded long before modern instruments existed. Medieval astronomers in China wrote of a wandering star from beyond the heavens that moved too fast to be local. In 1883, José Bonilla photographed hundreds of dark bodies crossing the sun, dismissed at the time as birds or debris. In hindsight, their trajectories don't match near-Earth orbits. The cosmos has been sending visitors forever. We just weren't paying attention. The difference now is that we are, and that attention comes with consequences. Planetary defense is a new phrase for an ancient impulse. When early humans saw lightning, they built myths. When they saw meteors, they built gods. Now we see a visitor from another star and we build laser arrays. Technology changes the expression, but not the instinct. Fear dressed as vigilance, curiosity dressed as control. Every civilization that reaches for the stars eventually faces this mirror, the realization that the unknown is not waiting to destroy us. It's waiting to define us. What we do in those moments becomes our story, and our story, more than any object, determines whether we endure. The Greek astronomers saw comets as messengers. The Mayans saw them as omens. The Chinese recorded them as warnings from the mandate of heaven, a celestial bureaucracy reminding emperors of their limits. Even then, across cultures, the symbolism was clear. When something arrives from beyond, you are being judged. If that metaphor holds, then 3i Atlas is less a threat than an audit, a measurement of who we are when faced with something we can't explain. The parallels don't stop with history. On a cosmic scale, interstellar visitors might be the rule, not the exception. Recent models estimate that every star ejects trillions of planet fragments over its lifetime, shattered remnants wandering between systems like cosmic seeds. Some of those fragments, researchers believe, could carry molecular archives, frozen records of the worlds they came from. Each interstellar comet is a memory, a story encoded in ice. If so, 3i Atlas is a letter from another sun, a messenger carrying not intent but history, And here we are, intercepting that letter with radar, decoding it through classified algorithms and burning holes in it with lasers. Humanity's reaction, if seen from afar, would look absurdly familiar. Every species that fears extinction first imagines an enemy. Every intelligence that glimpses the unknown first draws a boundary. We are creatures of reflex before we are thinkers. In that sense, our mobilization around 3I Atlas isn't just a response to one object. It's a symptom of a species rehearsing its own insecurity. When Oumuamua passed, we missed our chance to study it closely. When Tui Borisov came, we were still arguing about funding. By the time 3I Atlas arrived, we were ready. Not for discovery, but for confrontation. That readiness says more about us than the object ever could. The philosophical implications ripple outward. If interstellar visitors are common, then somewhere, perhaps millions of light years away, another civilization is watching objects from our system drift past their sun. Maybe they're doing what we're doing now, measuring, wondering, fearing. Maybe they too built a shield before they built a telescope. That symmetry should humble us. Instead, it seems to excite our paranoia. SETI researchers, those still allowed to speak publicly, describe 3I Atlas as the first candidate for reflexive observation, meaning we looked at it and it looked back. Not intentionally perhaps, but mechanically through energy coupling, through the way light and matter interact. Even in silence, the exchange between observer and observed is reciprocal. Observation changes the thing observed. That's quantum mechanics, and also human psychology. But what if reciprocity goes deeper? What if awareness itself is contagious across space, carried not by radio waves, but by curiosity? The moment we name something as alien, we give it consciousness in our minds. The universe might not need to communicate. It only needs us to listen long enough to invent the conversation ourselves. When the radar reflections came back patterned, the algorithm saw coherence, the humans saw intent. It's possible we're projecting our own order onto chaos. It's also possible chaos is mimicking order just well enough to make us look twice. In either case, the result is the same. We've turned a natural event into a test of civilization. Look back far enough, and this moment feels inevitable. In 1994, Comet Shoemaker-Levy 9 struck Jupiter, humanity's first real-time view of cosmic impact. It frightened us into funding planetary defense. In 2022, NASA's DART mission struck an asteroid, proving we could move one. That triumph seeded the architecture now trained on 3I Atlas. Each event, each discovery, each fear evolved into the next. A straight line of cause and consequence leading from curiosity to control. And in that line, a pattern emerges, not in the sky, but in us. We encounter mystery, we construct an explanation, and when the explanation fails, we construct authority. We've done it with gods, governments, and now galaxies. The pattern never changes, only the scale does. What makes 3I Atlas different is that it arrived at a moment when humanity was already stretched thin, politically fractured, digitally saturated, existentially tired. The object didn't just challenge physics, it challenged perception. Every image, every data drop, every public denial felt like part of a larger narrative, one that no one was writing but everyone was living. And in that shared confusion, something profound happened. For the first time in decades, the entire planet was watching the same object. We may not agree on what it is, but we are united in facing it. That, too, is part of the cosmic pattern. Whenever the sky intrudes, humanity forgets its divisions for a moment, only to rediscover them in the aftermath. If history is any guide, this too will fade. The comet will pass. The data will be classified, then forgotten. The defense systems will remain, waiting for the next anomaly. And one day, when another visitor appears, 4I, 5 6I will repeat the same ritual: disbelief, mobilization, control, and silence. But maybe repetition is the universe's way of teaching. Maybe it keeps sending visitors until we learn the lesson we keep avoiding, that not everything unknown is an enemy, that curiosity and caution can coexist without one devouring the other. For now, 3I Atlas is still visible, a dim smear of light in the southern sky. It doesn't broadcast, it doesn't threaten, it doesn't explain itself. It simply moves, indifferent to the drama unfolding on the small planet watching it. In that indifference lies the most humbling parallel of all. The cosmos is not hostile, it's just vast. And our fear of it, like a radar pulse cast into the dark, always returns to us amplified. We call it echo. The universe calls it balance. By November's end, the world was pretending nothing had happened. The data blackout continued, the press remained docile, and the official stance that 3i Atlas was just another interstellar comet held steady. On the surface, nothing looked different. The skies were calm, the network stable, the headlines numb. But beneath that calm, something fundamental had shifted. It wasn't the comet that had changed, it was us. Every system built to study the universe had been repurposed to defend against it. Every question about the unknown had been replaced by a calculation about risk. The transition was so smooth, so quiet, that most of humanity never noticed the threshold being crossed. But inside the agencies, inside the encrypted channels where people still dared to tell the truth, they used another word. They called it the countdown. No one knew what it was counting down to. Not a collision. There was never any impact threat. Not contact. No transmission had ever been decoded. The countdown wasn't to an event. It was to an understanding. And the understanding was this. 3 Atlas didn't need to do anything. His mere existence was enough to change the world. On November 20th, a classified report circulated through NASA's Planetary Defense Coordination Office. It was a final summary of all observations before the object passed beyond Mars's orbit. The title read simply, Status Concluded. The conclusions were brief, almost sterile. Emission variability continues. Source undetermined. No trajectory alteration beyond model tolerance. Recommend extended observation during outbound phase. To the untrained eye, it was anticlimactic. To those who had lived through the last 4 months, it was devastating. It meant they'd learned nothing. No confirmation, no explanation, no closure. The object had come and gone, leaving behind only suspicion and the infrastructure built to contain it. Within hours of that report, the defense networks began winding down. Sentinel-3 and Caduceus entered standby mode. Project Helios halted its laser tests. The Orbital Response Baseline, ORB Fire, logged its final readiness score, 99.3% synchronization across Allied assets. Success, by every metric that mattered. But success for whom? The scientists who had fought to keep the data public called it a funeral. Not for the comet, but for science itself. They watched as every raw dataset, every spectrum, every log file was archived under classified custody. The official line, preserved for long-term study. The reality, buried, hidden behind the same wall that now defined every aspect of human curiosity, the wall of national security. A senior astronomer at ESA summed it up bitterly. We used to build telescopes to look outward. Now we use them to look inward and make sure no one else can see. That was the end of the investigation, but the beginning of something else. Because while the systems powered down, the people inside them did not. A handful of scientists, engineers and technicians, the ones who'd built the second archive, kept recording. They documented every encrypted transmission, every deleted dataset, every overwritten parameter. They mirrored it across hidden drives, stored it in cold servers, sent fragments through anonymous networks. A digital ark carrying the last unfiltered truth. Their hope was simple, that someday, when fear loosened its grip, those files could be opened again. That humanity might study the unknown without turning it into an adversary. They didn't expect to live to see it. They only wanted to make sure the story survived. But even among them, the question persisted. Had we overreacted? Had 3 Atlas actually done anything worth all this? The evidence remained inconclusive. The 47-second emissions could still be coincidence. The radar echoes could still be noise. The mutual resonance event could still be artifact. Every possibility remained open, and yet deep down few believed it was all random. The precision, the timing, the geometry, it felt like a pattern too deliberate to dismiss. Still, the object showed no aggression, no deviation, no approach. It continued on its trajectory, leaving the inner solar system as quietly as it had entered. If it had noticed us, it gave no sign. If it had responded, it did so in a language we couldn't translate. Maybe it was never a message. Maybe it was a mirror. The mirror interpretation began circulating among the remaining theorists. The idea that interstellar visitors act as cognitive catalysts, that their role isn't to communicate, but to reveal what a civilization does when faced with something beyond comprehension, like a stress test for consciousness. If that's true, then 3 Atlas didn't come to threaten or teach, it came to measure, and the measurement was of us. We failed in predictable ways, through secrecy, fear, and weaponization, but we also succeeded in small, human ones, in curiosity that refused to die. In data saved by those who couldn't bear to see it erased, in whispers of truth exchanged through encrypted servers and midnight calls. These acts, invisible to the public, were the last defense not of Earth, but of honesty. In the end, the story of 3 Atlas will likely be written as a triumph of preparedness. The headlines will celebrate the success of planetary defense, the efficiency of the drills, the flawless execution of command. The official histories will omit the fear, the censorship, the debates about contact and control. They will say, humanity proved it could protect itself. But the deeper record, the one stored in the second archive, tells a different story. It says, humanity proved it could still be afraid. That fear now hums quietly in the background of every satellite, every telescope, every peaceful directive that carries a classified appendix. It hums because once you've militarized the act of looking, you can't go back to seeing. The infrastructure remains, like muscle memory waiting for the next anomaly, the next justification, the next visitor. One of the last scientists to leave the project, a radar specialist from Canberra, kept a journal. In it she wrote a single reflection that captures what most were too tired to say. Maybe the universe doesn't send warnings. Maybe it just sends reflections, and every time we call it a countdown, we're really counting down to recognizing ourselves. That's what the countdown was all along. Not to an impact, not to an arrival, but to a revelation. A slow realization that the universe doesn't need to threaten us. We do that well enough on our own. And as 3i Atlas drifts farther into the dark, a strange quiet fills the space it leaves behind. The data streams slow, the sensors rest. But the silence doesn't feel like relief. It feels like waiting. Because somewhere deep in the servers of Project Trident, one transmission remains unanalyzed. A faint echo, time-stamped from the final radar sweep before shutdown, is nothing more than a pulse, a ripple in the static, an artifact by every technical measure. But when one of the last technicians amplified it before deletion, she heard something. 3 rising tones, evenly spaced, familiar, identical to the pattern first detected in October. She didn't report it. She just listened once, and then whispered to the empty control room, "Goodbye." Maybe that's all it was, a farewell from an object that never spoke. Or maybe it was something else, one last reflection of our own signal, sent back from the edge of understanding. Either way, the message was the same. The universe is not silent. We are. And every time we prepare for war against the unknown, what we're really defending is the fragile possibility that we might one day learn how to listen.